Alright, moving on to chapter 10, and so here's our warm-up to start. So what I want you to do is I want you to take a second, pause the video, and name the following based on their degree. Okay, so not on the number of terms, based on the degree of each. So the first one would be a cubic, okay, because it's a degree of 3. The second one would be linear, because it's a degree of 1. And the last one would end up being quadratic, because it's a degree of 2. We are going to be specifically looking at the last one, the quadratic equations in this whole chapter. Okay, so we're kind of doing basic intro to start before we get into the deep teeth of these quadratic functions. Okay, so chapter 10, section 1, exploring quadratic graphs. Okay, so basically what a quadratic is, which for those of you that might have played this way back when, in Angry Birds, anytime you launch a bird, basically what happens is that a parabola is formed in some way or another. Sometimes it's more arced, sometimes it's more straight, but in the long run, it's still going to have this parabolic shape that is arcing. Okay, and what we have there is we have a peak, we have a top, or we have a minimum if we have our parabola going the other way, but that's kind of the general shape that we're going for with these. Okay, so a quadratic function, the basic setup for a quadratic function is that y equals ax squared plus bx plus c. And we have to find what a, b, and c are. And so that's our general formula that we have for this function. Okay, so let's say I have the following. So let's say I have y equals x squared, y equals 3x squared, and y equals 1/3 x squared. Now, if you have a graphing calculator, I want you to take a second. I want you to type those into your y equals function and graph each one of those to see what it looks like. I'll give you a second if you want to do that. Okay, so with these, when we graph them, they end up all having their main, what we're going to call our vertex, all at the same point. But the difference is that they all are opening differently. One's opening kind of normally, the next one is narrowed up, and the last one is widened out. And so what we have here is that the red, or the reddish, orangish function, that is our first one. So that is our base. That is if our number was, let's say, 1, our a value. And as you see, you go from 0, 0, up 1 over 1 on both sides. Up 1 over 1 on both sides. The next one, which is the 3x squared, is our blue one here. Okay, and as you see here, we start at our vertex, or our turning point, and then we go up 3 over 1. Okay, and up 3 over 1 on the other side. And that's how we do our kind of our first one. The next one, which is our 1/3 x squared, you see you get about 1/3. You go up 1/3 when you go over 1, up 1/3 when you go over 1, and that's approximately what those numbers are. Okay, so that's our that's kind of how it is. But as you notice, depending on what that front number is, it's going to change the graph. Okay, it's either going to make it wider or it's going to make it narrower. Now, the width of a parabola is the a value, so it's that number that's always attached to the x squared. Okay, so it's always the number attached to the x squared. If the value is greater than 1, okay, positive or negative, so I guess the absolute value of it is greater than 1, then that parabola is going to be more narrow. Okay, it's going to be squished together. Okay, it's going to look something like that. If the value, which we could say is the absolute value of it, is between 1 and 0, then that parabola is going to end up being wider. Okay, so the closer it is to 0, the wider it's going to be. Okay, so if it's a decimal that's less than 1, it's going to make it a wider parabola. If it's more than 1, it's going to make it narrower. It's going to kind of squeeze it together on each side. Okay, it's going to squeeze it together, making them closer together. You can think of it increasing faster on either side if the a is bigger than 1. Okay. Okay, so now let's take a second, take these and order them. Here, I'll give you numbers so you don't have to worry about writing out the entire function. So 1, 2, 3. So we've got function 1, 2, and 3. Okay, so take a second and order these from narrowest to widest. So I want the narrowest one, the ones that's going to be the closest, to the widest. Okay. Okay, so if we're doing these from narrowest to widest, the most narrow one is the one with the largest a value. And the one with the largest a value would be 3 because 9 is the largest number. Next one on here would be 1, and the last one on there would be 2. Okay, so 3, 1, 2 would end up being the order from narrowest to widest, because 9 is the largest number, and 0.24 would make it the widest out of those 3. Okay, so again, you're just looking at the a value. The rest of the function does not matter. Okay, so along with these parabolas, we also have our maximums and minimums. And our maximum and minimums, which I've already discussed, or I've already mentioned before, is at our vertex, our turning point. Okay, it's at either the highest point or the lowest point. So a parabola will either have a maximum or a minimum. A maximum is located if the parabola is opening down. So if you have a parabola that's opened like this, that was going to be your maximum. And your maximum is located at the vertex, which is the highest point there. Okay, and so we're going to talk about different ways of finding these. We're going to start off with some easy ones to find, and then we're going to make it more difficult as this chapter moves along. And so that would be where our maximum is located. So maximum is located at the highest point of the graph, which is at the vertex, okay, when it's opening down. Okay, it is a minimum if the parabola is opening up, and it's also located at the vertex. So if you have a parabola opening up, that point down there is your minimum. Okay, it's the point, it's the turning point of it. Okay, it's the lowest point of the graph. So every parabola is going to have a maximum or a minimum for it. They won't have both, because when you have a maximum, your minimum goes off into infinity, and we wouldn't say we have a minimum of infinity, okay, because infinity is not an actual number. Okay, so how to tell just by looking at the equation. So let's say I just give you a function and go, is there a max or a min? Again, you are looking at the x squared value or the a value. Okay, so you're looking at the x squared value on here, and the coefficient that's out front of it, or we could say just the a value. So if the a is positive, then we're going to have a minimum. So anytime you have an a value that's positive, so if the x squared is positive, your parabola is always going to be opening up, giving you that minimum. If you have an a value that's negative, that means that you're going to be opening down, okay, and that a value is going to be, or that maximum is going to occur. Okay, so the a value is going to tell you how wide it is, and also if it's opening up or down. If it's positive, it's opening up. If it's negative, it's opening down. Okay, so the a value is fairly important. Okay, so let's find the vertex the easy way. Okay, so this is not the easy way, but for easier problems. Now, if you notice with both these problems, they're both missing what? They're both missing an x value. So they don't have a b value in the middle. Okay, so it's just x squared and then the c. And so to find the vertex of these, which is the fairly simple way, all you have to do is you plug in a 0 in for the x. Because what's going to happen is that your vertex will always be located on the y-axis for these, if you have no x value, no b value. And so all we have to do is we plug in a 0. So we have 2 times 0 squared plus 3, which gets us a point of 0, 3. Okay, if I solve the top one, I end up with just 3. And so that is my vertex. So my vertex is just located there. So take a second, solve the second one, and see if you can find what the vertex is. Okay, so the vertex, again, all you have to do is you plug in a 0 in for the x. And so when you plug a 0 in for the x, we end up getting -7, which means my point would be at 0, -7. And that is where in this case, my maximum occurs, because this one is going to be opening down while this one's opening up. Okay, so the first one would be a minimum, the second one would be a maximum, but the easy way to find the vertex is to just plug in a 0 in for the x value. Now, that only works if there is no b value, so there's no x on it. Okay, so there's no x. Okay, so easy way to do graphing. okay, would be to just find the vertex and then find a point on either side, and then just pick points on either side of it going out. Because one thing that's nice with a parabola is that they are symmetrical. Okay, so once we know what the vertex is, which again, we plug in a 0, so it gets us at -4. So that means our vertex is going to be down here. Okay, and now we're going to plug in a point on either side of it. So I can plug in a 1 and a -1. When I plug in a +1, I end up with a -2. And I plug in a -1, I also get a -2. When I plug in a 2, I get, let's see, 2 times 8 is 8, so that would put us up at 4. So it puts us way up here when I plug in a 2. Okay, and then what we would do is that we would just connect those lines, and we get this nice little arc. So what you'd want to do is you find the vertex, and then pick 1 to 2 points on either side of it, and it's going to help you with the growth of that function. Okay. Okay, so your homework in this for this part is just section 1. It's going to be kind of covering everything, finding the widths of it, finding the vertex, and also rough sketches of yours. So find the vertex and then pick a point on either side.